Hi, this is a reply to one question a student had related to problem number 4 in homework 6.5. So this is homework 6.5, as you can see right here. And the question is question number 4. So I scroll down to question number 4. And this student had a question related to, here it is, G and H. So these two questions. G, it says find the probability. Let me just grab my spotlight first. Okay, it says find the probability that the sample mean fat consumption of the 34 randomly selected males in the US, age 40 to 49, is less than 104.1. In order to solve this problem, we have to first see that we are actually talking about mean fat consumption. We have a sample size, and I'll just write this right here, N, which is 34. And we want to find the probability that the sample mean fat consumption of this group, meaning X bar is a mean of the sample, is less than 104.1. Now, because we are asked to find this probability, and this is a sample mean, we have to use the central limit theorem. So we want to make sure we understand this. The central limit theorem tells us that, and sorry about this, this is my dog barking. So here is the sampling distribution of the sample means. What we know about the sampling distribution of the sample means that the mu X bar is mu. Okay, and the standard deviation is sigma divided by square root of n. Okay, now what is mu and what is sigma for this problem? In order to answer this question, I will have to scroll up, and bear with me. This was the G question for this problem, but the original problem is right here. And the mean, it says right here, is 103.1. So I'll write it down. Mu was given in the original problem as 103.1 grams. And the standard deviation was 4.32. And we have a large enough sample so we can apply the central limit theorem, CLT. The way we apply the central limit theorem, we identify the sampling distribution of the means and we find the parameters of this distribution. Now, the only thing that will change in our work when we use the normal distribution, the standard deviation will be actually sigma divided by square root of n. The mean stays the same. So I will scroll down now to G, because we are doing problem G here. And now, in order to answer this given question, what is the probability that X bar is less than 104.3, 104.1? Just remember that mu is 103.1. So right here, I have 103.1. I'll take the eraser and change it to 103.1. And now I'm looking for 104.1. Well, 104.1 will be to the right. I'm not sure where, but I will just put it here somewhere, 104.1. They're looking for X bar to be less than, so I will shade this area. This is the area we're looking for. So to answer this question, I have to find that area. To find that area, I will simply do probability that X bar is less than 104.1 equals to normal CDF, because that's a normal distribution, from negative E99 or negative 10 to the 99 power to, this is where I will stop if I were to move on the x-axis corresponding to the area above, which is 104.1. And then I have to enter the mean. And the mean of this distribution, we said before, equals to mu, and mu was 103.1. So this is what I have to enter right here. And comma, the standard deviation of this distribution, we said before, is sigma divided by square root of n. So sigma is 4.32, square root of n is square root of 34. The reason they say use the exact value of the standard deviation with the square root is you have to put in here the value 4.32 divided by square root of 34 and let the calculator figure that out. So it will be a more accurate result. This is the most important thing. You want to make sure that you change the standard deviation accordingly. That's the only thing that changes if you think of the way you've done the problems before with just the normal distribution. Okay, that's the only adjustment you have to do when it comes to using the central limit theorem. So I will take the calculator and find that answer. Here is the calculator, so I'll just simply go to normal CDF, hit enter, and I have to enter from negative E99 to 104.1, and then the mean is 103.1, and the standard deviation was, and I have to enter it exactly how it is there, 4.32 divided by square root of 34. The calculator will be able to give me a more accurate answer if the standard deviation is entered that way. So I hit enter. This is how it should look like. And here is the answer. They say round to 4 decimal places, 0.9115. 0.9115. So the answer right here, and I'll write this down. It is approximately 0.9115. This is how you answer this question, G. And let's check the answer. Here is the key, so that was the correct answer. Now for age, so I will clear this one now, just to make room for age. It says, find the probability that the sample mean fat consumption, again, we are asked for the probability of a sample mean, okay, of the same 34 randomly selected males is less than 101.7. Okay, so we will do it the exact same way. Keep in mind, we are talking about n being 34. The question is probability that X bar, a sample mean, it says right here, a mean, probability of a mean of a group being less than 101.7. That's why I use this notation. So when you sketch the graph, the sampling distribution of the means will actually be narrower. Is narrower. This is X bar. And the mean of the original distribution, if I recall correctly, was 104.1. And the standard deviation was 4.32. Which means from the central limit theorem, the mean of the sampling distribution of the means will stay the same. No, it was 103, sorry, I think it was 103.1, that's what it was, my mistake. And the standard deviation is sigma, which is 4.32 divided by square root of 34. Okay, so now this is 103.1, and I'm looking for an X bar. This is where I have the X bars less than 101. So here somewhere 101.7. I will simply try to find this area. This is what we are looking for. To answer the question, I'll simply use the normal distribution related to this distribution of the sample means. So right down here, probability X bar is less than 101.7 is normal CDF from, again, negative infinity to 101.7, and then the mean and the standard deviation. The mean stays the same, is the original distribution. However, the standard deviation changes, 4.32 over square root of 34. I enter this in the calculator, and let's see what we find. I cannot grab my calculator now. Here it is. Just move it here so you can see it. So it is normal CDF. As I said, negative E99 to 101.7. The mean is 103.1, and the standard deviation, copied from before. So here we go. So the answer is 0.0294, rounded to 4 decimal places. I put it right here, 0.0294. Click the answer. This is the correct answer. So this is it. This is about applying the central limit theorem. I'll write it down here. So the answer is 0.0294. The only difference between the normal distribution and the applications of the central limit theorem, the only difference is right here. You have to adjust the standard deviation. However, the problem, you have to make sure you are looking for the mean to be less than or greater than or in between some values. Because before this, if you recall the other problems, just for a normal distribution, applications, you are asked to find what is the probability that one randomly selected person is less than some number or greater, or questions like that. So it was an X, not a mean of a group. So keep that in mind. If it's just a normal distribution application, you just use normal CDF as it is without adjusting the standard deviation. If it's an application of the CLT, the question is phrased in such a way that you have to find the probability of some mean being less than, greater than, or in between some numbers. And if you realize that's a mean, that means right away you have to apply the central limit theorem, adjusting the standard deviation. I hope that helps. Let me know if you have questions.